speakers
This
from
conference
Germany.
will now be recorded.
A special guest, Mr. Rajneesh Khosla, esteemed speakers from Germany and India, members and friends from the industry. A very good afternoon and good morning. Welcome to the web seminar on safety of machinery, preparing the industry on technical regulations, being organized by the German Engineering Federation, VDMA. Before we start, I would like to request all the participants to kindly keep themselves muted and please use the chat box for all the questions. Friends, the German Engineering Federation, VDMA, is an association of the German machinery and plant manufacturers with more than 3,300 members and over 1 million employees. It is the largest industrial association, not only in Germany, but in the whole of Europe. We cater to 38 specialized sectors under the mechanical engineering umbrella. Our members produce machinery worth 232 billion euros and export 78% of it. Having our head office in Frankfurt, we are also present in Brazil, in Russia, in India, China, Belgium, and Japan. Friends, we would like to take this opportunity to announce that VDMA India is planning to come out with an annual edition of VDMA Standardization newsletter to help our members stay informed about the technical regulations and guidelines relating to machinery safety and to promote a safe and secure machinery operations in the manufacturing industry. We would request forwards from VDMA Standardization Division, GIZ, BIS, as well as the Department of Heavy Industries, Government of India, and seek support from our members in terms of participation through advertisements, write-ups, case studies, troubleshooting manuals, which could be useful for the machinery manufacturer. This newsletter will have a circulation of 6,000 copies. In case of interest, please feel free to contact us. Friends, we have offices in different parts of the country. We have office in Mumbai, in Bangalore, in Kolkata, in Noida. Our operations in India is headed by Mr. Rajesh Nath, our managing director, and in the west it is Mr. Hindi John. In the east, Mr. Sandeep Roy heads the operations, and in the south it is Mr. Manohar and myself in the North India office of VDMA India. Friends, to the web seminar today, we would like to throw light on the importance of standards for safety of machinery and inform the industry about the upcoming technical regulations. In fact, friends, using machinery and work equipment exposes workers to multiple risks. Ensuring machinery operator safety requires application of safety measures as effective as possible. Technological development allows for designing more and more effective protective devices. The role of control systems as applied to risk reduction becomes more and more significant. Considering the important role that digital technology is playing in helping machineries operate safely, this webinar will give a good overview of machinery directive requirements and the benefits of adopting digital solutions for safe operations. So to talk about this subject, we have with us our speakers, Mr. Rajneesh Khosla from the Bureau of Indian Standards, BIS. Thank you, Mr. Khosla, for being here. Mr. Carson Gurus from Phoenix Contact, Mr. Amol Bari from PILS India, Mr. Ramji Singh from Schmersel, Mr. Jayesh Jani from ZIC, Mr. Wagner from the VDMA Frankfurt office, and of course Mr. Nath from the VDMA India office. So the program is as follows. So we'll start with the welcome address from Mr. Rajesh Nath, and then special address from our special guest, Mr. Rajneesh Khosla from BIS, and then the presentation from our other speakers will follow. With this, I would like to request Mr. Rajesh Nath for his kind address. Mr. Nath is next. Mr. Nath has more than 20 years of experience working in various industries in Germany and India. He's accorded the Cross of the Order of Merit, highest civilian award for the from the German president. So he is also promoting the Indo-German trade for quite many years. So we are happy that Mr. Nath is with us today, and I request Mr. Nath for his kind words, please. Over to you.
Yeah, thank you, Ajmal, and good afternoon, Mr. Khosla, and all our speakers for today, as well as all our participants. Friends, we all benefit from safe machines, machines that conform to relevant safety requirements, protect workers and the environment. Safe machines also contribute to efficient production processes and thus are a key pillar of a robust economy. However, a working culture that acknowledges the importance of machine safety requires comprehensive regulations substantiated through high standards and elaborated conformity assessment procedures. Hence, our web seminar today on safety of machinery, preparing the industry on technical regulations, gains immense significance. We feel privileged and honored to welcome Mr. Rajneesh Khosla, scientist and head MED, Bureau of Indian Standards. Thank you, Mr. Khosla, for joining us today. My colleague from VDMA, Mr. Herman Wegner, and our esteemed speakers from Phoenix Contact, Pils, Schmerzal, and Zick. Hence, the Indo-German Working Group on Quality Infrastructure, in which VDMA is an important stakeholder, and where our colleagues, Mr. Wegner and Mr. Newell, are regular participants, has been a very conducive forum to discuss the significance of safety. German and Indian regulators and industry experts have not only exchanged information to understand each other's approaches, they also shared experiences on how to develop new and existing regulations and standards related to functional and electrical safety while drawing on European good practices. Beyond the ethical responsibility, the short and long-term financial benefits of ensuring safe work equipment like machinery and safe workplaces are recognized globally. Accidents damage the reputation of firms and lead to production losses. The ILO estimates that accidents and work-related diseases cost the global economy around $3 trillion annually. This is why both machinery and worker safety are crucial topics for every firm, every worker, and every policy framework also. The application of the ILO recommendations is an important step to improve workplace safety. Safer work environments are receiving increased attention, not only in India, but in other emerging economies, where industry best practices are being actively adopted. During the past few decades, a growing number of countries have recognized the value of these measures and developed and introduced safety requirements in accordance to their national laws. Successful implementation of safety culture involves a specific understanding of the needs, standards, technical regulations, and the conformity challenges a country faces. Separate national developments have created various standards for identical products and vastly different procedures for gaining access to markets. New manufacturing technologies such as Industry 4.0 and the use of Internet of Things (IoT) could play a role in enhanced machinery safety, perhaps using a new ways of tracking processes as well as machine performance. The present regulations do not adequately reflect the technological advancements made in manufacturing processes. The culture of safety and corresponding low perception of safety in the industry, along with reluctance due to perceived costs of safety installation and equipment, needs to be shifted. The awareness about the value addition brought by the safety features and its impact on reducing downtime and enhancing productivity at large is limited. A comprehensive awareness raising campaign paired with capacity building is needed. To achieve this, incentives and recognition for those installing and maintaining safe machines is an option. Manufacturing in India, friends, is undergoing changes with programs such as Make in India. These changes will also bring in interconnected manufacturing technologies such as Industry 4.0 and require a more structured approach for machine safety and regulatory framework. The adoption of standards from ISO and IEC will support a smooth coexistence of different industrial stages of development, a key factor for the upcoming industrial development of India. The regulatory framework in India is supported by three government pillars: the Ministry of Labour and Employment, Bureau of Indian Standards, and Ministry of Heavy Industries and Public Enterprise. Friends, BIS has a long institutional history reaching back to 1946. It focuses on both interest of consumers and industry and is involved in various activities including standards formulation, conformity assessment, laboratory services, training, and information services. With this, I extend a warm welcome to Shri Rajneesh Khosla, Scientist and Head MED, Bureau of Indian Standards, and invite him for his address on role of BIS in standard formulation and overview on machine safety scenario in India. Thank you, Mr. Khosla, for joining us today, and we look forward to your address and interaction. Thank you very much.
Mr. Khosla,
Yeah,
you're muted.
Mr. Khosla, you said yes. Mr. Khosla, we can see your presentation, but we cannot hear you, Mr. Khosla.
Respected Mr. Rajesh Nath, am I audible?
Yes, Mr. Khosla. Yes, please go ahead. Yeah.
Respected Mr. Rajesh Nath, respected Mr. Wagner, respected distinguished speakers from India and Germany. I am Rajneesh Khosla, and I first would like to thank VDMA for giving me an opportunity to speak in this seminar. In my seminar, I would be trying to cover the role BIS has taken in the formulation of standards on machinery safety, and what are our interactions with the Ministry of Heavy Industry to smoothen the regulations and the standards that are to be covered in the regulation. So with this, I will start my presentation. Everybody knows that machinery safety is an integral part of product safety, and it is possible only with the involvement of all the employees of an organization. Next. The concept of machinery safety started in India in 2016 when the National Capital Goods Policy 2016 was formulated, and the major point in that policy was the reduction in the incidence of work-related injuries, fatalities, which is a national loss. And the policy highlighted the need for formulation of regulation and standard in order to ensure the safety of the machines as well as the laborers. There are machinery safety regulation present in India. We have the machinery safety regulations which are covered under the Factories Act, that is in 1948, amended in 1987. However, this act does not cover the design part of the safety. It only covers the occupational safety and health at workplace. So this is not the design part of the machine is not addressed in this regulation. Hence, the need for a new regulation in order to ensure safety of design. BIS has adopted the ISO 12100 safety of machinery standards and associated standard of ISO TC 199, which are the type A and B standards, which can be used now by Department of Heavy Industry and Ministry of Heavy Industry in order to form the regulation, which will be which is the thinking as per thinking will be in the line of the European Machinery Directive. The other regulation next in the machinery safety is the DG Fastly, that is a Directorate General of Factory Advice and Labor Institute, and they are the basically the onus of implementing the Factories Act lies with them. We next we also have another regulation on the safety of the workers, the Dock Worker Safety, Health and Welfare Act, and the Building and the Other Construction Worker and Unorganized Worker Social Security Act 2008, covering specific areas like it is given in the name of the machinery safety regulation. Next. It is a lot of machinery safety standard has been published, I think previously by EN and then adopted by ASU, and so a large number of standard have been published, and the European Machinery Directive is also in place and is being implemented. So it gives us a right example to learn how the machinery safety directives were followed and what are the lacunas that the European countries had to face, from which we can learn. So next, so the hazards that can come may not be limited, but the following are the most common hazards that in the workplace is encountered by the workers: the mechanical hazards, the electrical hazards, thermal hazards, hazard due to noise, vibration, material, ergonomics, and the surroundings. And next, the hazards may happen at various places. It may happen during the transport, it may happen during the commissioning, the setup, the normal operation, maintenance, decommissioning. So at any point of action in the of the machinery, in the life cycle of the machinery, the hazards can take place. Next. The risk estimation and risk evaluation is another very important part to analyze, and first to analyze and then to evaluate and then to reduce the risk. We have the RPM, risk priority number, which can be derived from the formula given on the board. Then based on the risk value, we can then devise the risk reduction strategies like the elimination of substitution by changing in the machine design, the engineering control, the administrative measures. So all this can lead to risk reduction. Next, regarding the present status of standardization in India, we have a sectional committee MED 40, which is a mirror committee of ISO TC 199. This is looking after the work of safety of machinery. As you all know, the Secretariat of ISO TC 199 lies with DIN. And BIS has been totally committed to adoption of international standard in the machinery safety arena. We have adopted all the standards that have been published by ISO TC 199. The Type A standard 12100 being the basic standard, and all other standard Type B standard that are supporting it. Next. So we have classified two standards as Type A standards, one in the design part, other the electrical part. The rest next are the Type B standards, which we have adopted. Next, the examples are indicated in my slides. Then we have also adopted a lot of Type C standard, which next, which are basically a lot of Indian standard as well as all the ISO standard that are related to the particular machinery, like for particular machine, like for heavy equipment, we have adopted the ISO standard on safety of earth moving equipment. There are 17 parts in it, and all have been adopted. So similarly, we have some indigenous standard and other international standards which are related to the particular safety related aspect of the product. So what is the way forward? The way forward is next, the exchange of information and sharing of expertise on machinery safety standard between the European, the German manufacturers and the German ministry and the German manufacturing association and the Indian, so that the awareness can be created amongst the Indian industry people. The second is, which we are working actively with GIZ at present, is preparation of an industry guideline compiling regulatory provision related to machinery safety for easy use by the industry. So how the machinery safety standards can be implemented by the Indian industry. We are in touch with GIZ to formulate sector specific guidelines as well as general guidelines for its implementation. The third is active participation in the working document of ISO TC 199. As far as the status of the technical regulation is concerned, as you are all aware, we are in the midst of a pandemic right now, and all the regulations generally are on standby mode right now, because the government does not want to burden the industry with regulation at this juncture. However, I think DHI, a person from DHI would be able to tell that when will they again be starting to look upon this regulation, machinery safety regulation, as and when the situation improves. I think they will be again trying to implement this regulation as fast as possible. However, at this time, I think all the regulation have either been postponed or are in standby mode. So, however, the details are still awaited. We are also waiting details from Department of Heavy Industry as to when the implementation would actually take place. With these words, I would like to thank again the VDMA for giving me an opportunity to give my presentation in front of such august audience. Thank you so much.
Thank you so much, Mr.
Thank you,
Khosla.
thank you, Mr. Khosla. I think very good points you touched upon. I would now like to hand it over to my colleague Ajmal to take it forward. Thank you, Mr. Khosla.
Thank you so much, Mr. Khosla. It is absolutely an honor to have you with us today. You also gave a good overview about the role of BIS, as well as giving us what are the different types of safety standards which are going to come up in the upcoming technical regulations. Thank you for the crisp presentation. Our next speaker is Mr. Carson Gurus, Senior Specialist Phoenix Contact. He is going to present on the topic of global trends in safety of machinery, new requirements for PL and SIL. Over to you, Mr. Gregorius.
Yes, hello everybody. Good afternoon to India. I hope you can hear me, the audio is okay, I hope. Yes, thank you for the introduction. As already said, my name is Carson Gurus. I'm working for Phoenix Contact, and I'm a member of the standardization committees of two, let's say, international standards. On one side, the IEC 62061, and on the other side, the ISO 13849, which are both, let's say, dealing with the aspects of functional safety in the context of machinery safety. And yeah, today I would like to give you an overview what will change in the near future with these both standards. Because these both standards are covered, let's say, by, several hundreds of B and other C standards under the machinery directive, and so it's a quite huge impact. These both standards have a quite huge impact on the machinery safety in general. And yeah, I would like to give you an overview. Okay, maybe you can go to the next slide. Can you go to the, yes, thank you. So here on this slide, here you can see, let's see, the relation between these both standards. For those of you who are coming from or already have good experience for long years with functional safety, you may know the EN 954, which was the, let's say, basic standard for functional safety, let's say 20 years ago. And based on this standard, the EN ISO 13849 has been developed, let's see, yeah, around 20 years ago. And this standard is, let's say, covering all aspects of functional safety with the so-called performance level. That was, let's say, the main aspects came from the let's say, generic standard IEC 61548, which is also familiar, or the sector standards are familiar for process industry, for example, the IEC 61511, which you see on the right side. And also for the machinery sector, we know the sector standard IEC 62061. And both sector standards are covering the aspects of SIL, or a safety integrity level. So that means, in fact, we have to deal with two standards for machinery safety under the machinery directive today: ISO 13849 with the PL performance level, and IEC 62061 with the SIL level. Which makes it a little bit more difficult sometimes, but yes, on the other side, I would say from my stomach feeling, more than 90% of the machine designers are using the ISO 13849. Therefore, I will also take a focus on this standard today. Yeah, maybe you can go to the next slide. Here you can see how these both standards are embedded into your, let's say, Indian structure. We have heard about that the MED 40, which is your, let's say, safety regulation for India, that both standards are listed here. On one side, the IEC 62061 with a version of 2005. There are two other adoptions or amendments in the meantime. And there is a final draft available called ISO 13849-1, which from 2015, which you see in the let's say, below. So both standards are, let's say, embedded in an integrated part of your MED 40 regulation in India. So maybe you can go to the next slide. So what is the time schedule for the revision? Because the revision is that important that there's you will see that there are main requirements will be changed and adopted, which were not there in today. So the IEC 62061, the revision of this standard has already adopted from the International Committee of IEC. So it's just a question of, let's say, weeks or months when this new version is available. Okay, so hope you can hear me again. There was a disturbance. Okay, so and the ISO 13849, which you see here, is also under revision. On ISO level, it is planned to have the final release beginning or mid of next year available. So here it's you say the project is has taken a prolongation, which will come active or which will definitely end in June 2022 next year. So you can see, so it's a very close revision is very close to be expected. And I would like to give you an overview of what will be the main aspects of this revision. Maybe you can go to the next slide. Yes. So one aspect which we know from the safety of machinery is that the most incidents or near incidents or also the accidents are caused by, let's say, a wrong safety specification, and that is the reason why there was a special focus on have a better or precise definition. What is the so-called the safety requirement specification, how this may look like. And on this slide, you can see that is in principle divided into 6 steps. So the first question is, for example, what is your triggering event? So for example, on a machine tool, we say that the opening the front door, for example. What is the safety reduction out of that? So that means the control stop has been activated from the drive systems. What kind of dangerous part in the third step are affected? For example, spindle A1, for example, when you think about a machine tool, we have different movements which need to be monitored in this case. As a fourth case, we have the operating mode to be defined. Is it an automatic mode or is it a manual mode? What is the demand rate as a fifth element of the SRS? And as the final description, what is the expected reaction time I need to take into consideration, because this will definitely have an impact, for example, on the safety distances of the machine. So this is an example how a safety requirement specification may look like. And on a typical machine, you maybe have, let's say, 20, 30, or maybe 50 safety functions which you need to take into consideration. Maybe we can go to the next slide. Another aspect which is covered in this ISO 13849 is the aspect of safety-related software. Maybe the most of you knowing the so-called V module for software validation, which looks like more or less at this stage. So it's a little bit, I would not say complicated, but it was developed for, let's say, embedded software, for example, and things like that. And for this kind of software languages, these so-called FVL languages, full variety languages, this is still valid. But we know from the technology, many machine designers are using so-called pre-certified or pre-designed safety systems like safety PLC, safety controller, safety configurable safety systems, where the original component supplier has already done a kind of pre-assessment for their function blocks. And if you have these kind of systems, the validation process will be simplified. And here, when you click on the mouse, maybe you will see that. Yes, you will see that as a new and simplified V module for so-called LVL software languages, like function blocks languages, for example, and things like that, has been or will be possible to be used. So in principle, there's just a 3-step: the safety requirements, software specifications, the coding, and the testing. So it's a very easy approach for the software validation part here. So it's a simplification which this new standard will bring to you. Okay, and as a last aspect for today, for the new revision, that is a quite new aspect which has never, let's say, addressed in the past of functional safety, at least not in the standard. That is the aspect of cyber security, and this become more and more important because we know there was many different attacks in the industry over the last couple of years. For example, the Stuxnet virus, we know router failures from Telecom, the Vinti Tessen Group, the WannaCry Triton, which was the first virus and attack on an SIS and on a safety integrated system. So we see this aspect of cybersecurity becomes important also for functional safety. And due to this fact, both standards has decided to address this aspect also in this standard. And maybe if you go to the next slide. Here we can see that in many cases it's a kind of, let's say, compromise. That means on one side, on the left side, you see there are aspects which are dealing with functional safety management, with other aspects of risk assessment, for example, as they are described under the ISO 12100 on one side. On the other side, we now, let's say, cybersecurity aspects which will get in conflict to the aspects of the risk assessment, for example. So, and that needs to be solved in a way because the measures for the security risk assessment, which needs to be taken into account in addition to the safety risk assessment, as you know, from ISO 12100, are a little bit different because they are also addressing the end user case, for example. And all in all, you will come up to final decisions that both requirements come together on the aspects of the control and automation systems later. Maybe go to the next slide. What does it mean in reality? So what might be the consequence when you talk about cybersecurity in the context of functional safety? For sure, we know safety-related systems, like here in this case, a configurable safety system, which is programmed and which has, let's say, a gateway and a USB port, for example. All these are access points for, let's say, external hackers and others. So that means there are access points which may cause in the final end that safety-related functions like stopping functions for the machine drive systems, for example, will not execute it longer. So if it's possible for a hacker to change the safety-related configuration in that way that this will affect the safety configuration in a negative way, the worst-case scenario might be that it would not longer, this safety-related action would not longer performed by the controller. And that's for sure needs to be avoided, and therefore predictive measures must be taken into account. And how this may look like, we see on the next slide. Yes, so the idea is to let's say separate the automation system in different so-called zones. One zone, for example, is the zone A, which you see in the center on the left side with the yellow controller. This includes the safety-related sensors and actuators, and for sure also the safety logic controller. And this is the so-called the core PCE safety equipment. This zone A contains all direct related safety-related parts of the control system. And the next zone, on the zone B, you see you will find all the access points like human interfaces, HMIs, programming devices, and so on. But this zone B is encapsulated by conduits, which you can see here. So that means just authorized information and equipment are allowed to communicate to equipment in the zone A. And last but not least, let's say corporate infrastructure, the IT infrastructure, the officer IT, that is in principle outside this zone B, that is also encapsulated from the other zones by, let's say, firewalls and other measurements and gateways. So that is the idea of how, let's say, an overall cybersecurity approach may look like for covering the aspects of functional safety. As they are described in both standards. Okay, yeah, maybe last but not least, so what can you expect from Phoenix Contact in this case? For sure, on one side, the competence we have, so that means we have a certified functional safety management system in accordance to IEC 61548, which ensures that our products and developments are in accordance to the standard on one side, but also we have a certification to IEC 62443, which is, let's say, the basic standards, the counterpart of the 61548 under the aspect of security. So both standards are requiring, let's say, management systems where we have the approval from TÜV in this case, so that allows us to, let's say, perform the adequate management processes as they are required from the standards. And if we go to the next slide, you will see that deals and means that the complete portfolio from Phoenix Contract, you can be ensured that this is covering the aspects of, on one side, IEC 61548 for functional safety and as well for cybersecurity 62443. Okay, that was from my side. Last but not least, mention to my colleague Lalit Jain. I think he's also participating today. He will be your, let's say, first contact with all aspects of functional safety and cybersecurity. Thank you so much. And yes.
Thank you. Thank you so much, Mr. Gregorius, for an excellent presentation on the technological requirement for the machinery safety, as well as you covered about the control systems in the cybersecurity risk reduction. We have our next speaker from PILS India. He is Mr. Amol Bari. Mr. Bari, may I request you to kindly share your screen, your presentation, please. So Mr. Bari will be speaking on the topic of adopting digital solutions for safe operations. We will take all the questions from the chat box. So whatever questions you have, you may please put up on the chat box. We'll take during the question and answer sessions. Mr. Bari, over to you. Thank you.
Yeah, good morning, Brignar. Good morning, Mr. Gurus. Good afternoon, VDMA member, and good afternoon, all participants. So, the topic, that is the safe operation in plant machinery. Now, we will talk about the adopting the digital solutions for the safe operation. So, when we are talking about the digital solution, so always there is a technology innovations in the automation field, or we can say the industrial field. So what are these technological innovations happen in the with respect to the safe operation? If you see, there is an earlier technology everyone knows about. There is a traditional hardware technology normally we use for the safety in the machineries. So when we talk about the hardware system, that time it is a very complex system because it's all hardware, then taking the wires, connecting it together, and get the functional safety in the machine. This type of system is very difficult to troubleshoot. So whenever there is a breakdown, we will get maximum time to troubleshoot it. So with the new technology, we can have a digitalization, and with that technology, we can use a safe IO function blocks, which connects the system with safety capable networks such as a safety net, Ethernet IP, or the Profinet. So these type of such fieldwork systems, which gives the flexibility to use the safety in the machine, where we can get the we can get the advantages like easy diagnostic, easy to troubleshoot with diagnostic information which will be available on the devices like human-machine interface or man-machine interface. So this is the new technology which can be used for the safe control operation in the machine, which will give you the diagnostic information, and in turns we will get we will utilize your less time for the troubleshooting and get the system up with a minimum time. So what exactly this safety digital automation system is? Now, okay, we know about we are using the safety in the machine. So in the early days, we use a automation system, or we can call it as a standard automation system, and another is a safe automation system. So there are two different discrete control systems we normally use in the automation of the machine, or we can say the machine automation. So, and how these two systems, control system, those two discrete control system connects together with the fieldbus technology. So fieldbus technology gives the connectivity and intels, which reduces the hardware design as well as the implementation cost and better diagnostic with the software control. With a new innovation, now we will have the integrated safety in the standard plant automation, or we can say that safety and the standard control system in one unit. So it is the integrated safety system. So it's a single automation platform which meets safety standard, which meets the safety standard and efficiently operate the plant with central control. As it is an integrated control system and it is manufactured with the required safety standard, so we will have, or we will get a connectivity inside the control system, and which will have a central control system to operate the plant very efficiently. Now, what advantages or what is the edge over we can get with this safe digital solution? So when we are talking about this safety automation or safe digital solution in the control system, so we can get the flexibility, like we can create the safety zones and which can be managed independently with the safe IO functionality. So in any discrete control system, we can have a different zoning for the different operations where each zones are not dependent on the other zones for the safety aspects. Then we can get the flexibility in communication using the open communication protocols. So that is again the major main advantage of this digital solution. Data transport across several plant floor physical networks. So we can, with this digital network, we can pass on the data from one physical network to another physical network. So it is a very easy to get the information of one plant to the another. With this safety application, with fast response time, and or we can say that with digital technology, we can get the fast response for the safety application as well as speed of the system configuration, because it is easy to configure. Testing is very easy, and at the end, the commissioning of the product or the commissioning is very easy with this technology. Now, we talked about the Industry 4.0, what exactly it is. So it is all about the digital technology based on the safety aspects as well as the security aspects of the plant machineries. So it is nothing but a networking of virtual objects with the real world. So if you see, this is one application where you can see these are some integrated machine. What benefits you can get it? Like you can see that there is a flexibility. This means machines, modules that are in network but still function independently to one another. So you can see that there are three different machines integrated. Then you can get the transparency through the visualization, because all these equipments are connected together with a network facility or the fieldbus communication facility, and with a central visualization visualization device, we can get the all diagnostic, all the information about each on the visualization. So it is a web-based visualization, or we can connect all the equipment through the internet network also. Then this system is having the intelligence, like intelligence workpiece carrier. So each and every, with the help of RFID technology or the RFID chip, which gives the information of the next production plan or the next production step. So this type of technology will give you the modularity in the functionality of the machine. Then another main aspect of the machinery is the emergency stop, that is electrically activated, which can also be give a indication with the help of illumination. Individualization of the production. So the customer determines which product we want, or we want to make, we want the operation on that particular machine. So like for example, if it is an engraving machine, so if we want a product with an engraving with a different shape, then you can make that particular setting with the help of this modularity or individualization production functionality of this network. Diagnostic, again, sensor is having the intelligence, so sensor itself will give you the information about the diagnostic. What is the present state? What is the error state? So this type of diagnostic, we can get it with this new technology, digital technology, and that is connected to the central control system, and you will get the better diagnostic from the input devices, control devices, as well as the actuator devices. Then flexible control, as it's an automation system with quick reaction time, and as per the requirement, we can change the recipes of the recipes of the program, and you can get the flexible controls in terms of operation of the devices. Now, when we are talking about all this digital network or digital automation in the safety, so definitely when we are talking about the plant safety, so the digitalization of the data transfer from one network to another network is a very important. And if you see, this is a communication module with OPC UA, where the different networks like IT network and the operational network both are connected together. Like there is an administrative cell where the entry point, or we can say the all the information about the system, we can get it. Then there is a factory section where the different types of machines are installed, and that information we need to pass it to the central network. So might be there is a press machines, might be there is a robotic sales, might be there is a mobile robots like AGVs and other things. So all are interconnected and give the information to the central control system, and as per that the data is transferred to the cloud system, and then that in a secure way we can save that data in a on the cloud with a different security aspects. Now, when we are talking about this digital automation network, then safety and security, these two aspects are very important. So when we are talking about these automation plants, where the reconfiguration of the modular plants quickly and flexibly is required, then what we need to do? So safety solution must handle this flexibility through risk assessment and safety validation for the functional safety. As we are going for more and more automation, where we require a modularity in the plants, where we require the different models to be manufactured in one setup. So that time we need to take care of the functional safety of the machine when there is a change in the configuration, or the change in the configuration of the plant with a flexible manner or a quick manner. Other way, if this particular aspect is a safety aspect of the machine or safety aspect of the plant. But other way, there is another aspect that we call it as the security aspect of the security of the, aspect of the automation, that the networking of the equipment and threat of cyber attacks. So for that we need to have a secure solution with the cloud storage of the all data of the machineries, with an IoT gateway or the IoT gateway and the security bridge which protects the data from the cyber threat. So safety and security is a very important part when we are talking about the digital communication in the plant automation. So as a concluding note, we can say that the new digital automation technology solution, global safety standards, helps to ensure a safe workplace, boost productivity, and reduce environmental impact. So, like in earlier presentation, we saw there is a new advancement is happening in the functional safety, like the performance level ISO 13849. So new aspects about the functional safety, where the more functional aspects can be taken care depending upon the process, as well as the cyber security aspects. So both the aspects comes together, means considering the process, what needs to be done as a functional safety, as well as when we are talking about integrated plant or the physical network has to be connected, then the security of the system is a very important. So the functional safety point of view, machinery safety risk assessment is very much important, as well as when we are talking about the security system, security risk assessment is very important, and the safety standards, the global safety standards for both the system will merge together, and we will get a safe operation in the machinery safety with the digital communication or the digital network. So thank you. If you have any question, then I think we need to go with the question and answer session at the last.
Yeah. Thank you, Mr. Bari. Thank you so much. Absolutely, you rightly said that the safety standards as well as the automation go hand in hand, and you also talked about the application of Industry 4.0 in machinery safety. So that is very nice, good presentation, Mr. Bari. I would quickly go to the next presentation from Shmersal. We have Mr. Ramji Singh, Vice President Shmersal, India. He will talk about Technicum, your partner for machine safety solution and services. Thank you, Mr. Singh. Over to you, please. Mr. Singh, please unmute yourself, please.
Variance, and now this whole variance is going to the family. This is all the same. So this kind of practice.
Yeah, you are unmuted, Mr. Singh. Now you can continue.
Yes. So. Yes, sorry for a little bit delay. So first of all, thank you very much for the VDMA team and Mr. Nath for organizing such kind of important session, which is really good for Indian industry, and also bringing all the expertise who are in the similar field to share their expertise and their knowledge to make more awareness in the market. So basically, I want to touch about on this our activity within this Shmersal group. So I would like to highlight that we have a Technicum within the Shmersal group, and Technicum has been formed for the purpose of supporting to all the industry globally to enhance the safety, making the awareness. So I would like to touch that on the Technicum side. And basically, our group, if you see the group goal, is together with the customer and partner, we are turning workplace into the safer place. To achieve this, Technicum team is going to play a major role, and main advantage to differentiate and keep the separate Technicum so that they can play a role as a neutral approach every time and everywhere. So they are giving the independent consultancy and their guidance, awareness to the industry as an independent, and they play a role as a machine safety consultant. So I would like to highlight the major role of Technicum, why Technicum is required within the group. So first role is the academy, who does the lot different kind of seminars, trainings. Then also they does the different kind of consulting like risk assessment, lockout tagout. They also support for the C conformity assessment. So different activity. They also support to the industry for the engineering, for the safety, validations, then also the integration. So this is the major role of the Technicum team, which is helping to the industry to enhance their safety level. For example, some of the example I can say that they are helping the industry first of all to in the services. One of the example like C services. Another is also to implement the safety as a complete package with the either mechanical, electrical, pneumatic, hydraulics. So they take the complete responsibility to enhance the safety level to the industry for any kind of machine. So they involve also into the implementation. For example, I can show you one of the case study here. How it works, how the Technicum works here. So if you see, there is a machine and there is a different hazards. So this is a more in elaborative manner, but I have shown the profile of Technicum. So they are involved like into this review of the safety as a consultant. Then there is the assessment, then project development. There is a part of engineering, implementation as applications, then documentation for related to the engineering, then training. Training is part of academy, and you can also see the different hazards, safety hazards is available on the machine at the time, at the beginning where it is being used, or maybe at the development of machine. And once this is completed, how it is going to look, and then we also validate. So this is the complete profile of our safety consultant who work together with the industry, customers and partner. And then finally, major aim to achieve to make the machine like this, so that any person can work in a safe condition. This is our final goal, to achieve the safety. Now I would like to highlight, you know that in the world there is a international legislation, and every part of the world having a different kind of safety. Like international standard, we can say IEC and ISO. In Europe, you all know that we follow EN, ISO, IEC. In Asia especially, we have a mix. If you see, we follow the different kind of things. Like in India, we are following the BIS, Bureau of Indian Standard. We also follow some places GBT, then EN, ISO, IEC. So all the mixed things is available in Asia, and in India also we follow in the same manner, and in US they follow OSI standard. But I would like to touch upon this here, especially for India. Simarsal is one of the key member of the, as Mr. Khosla has indicated, they have a committee, and Simarsal is one of the key member of that committee to provide their expertise and guidance to help them to enhance the Indian safety standard. So we work together with BIS here to provide all our expertise and guidance, and where Technicum team is involved to work together with them in the committee. So where we worked, what we does. So you know that principle of machine safety basically divided in three parts. Type A, as Mr. Khosla also mentioned, that type B is a just basic standard. Then type B has been divided in two parts, type B1 and B2. Basically B1 is, you know that how to use the safety product, where this B1 comes into the picture. And B2 is coming is that how to manufacture the safety product. So in the manufacturing, you know that there is a certain parameter to be followed to achieve the safety and define that this is a safety product. Like one of the example I can say, to define that, to limit the values. And third is the type C. Type C comes into the different kind of machinery. So there is a different standard for different machinery. So the same thing I can see, this is a something little bit more elaborated manner. What is the meaning of type A, type B and type C? So you can see that type A where we follow the design and risk assessment and also the risk mitigation, where ISO 12100 comes into that. B1, you can see that there is a 13849. We follow like safety distance is one of it, how to use the safety product. For example, if you are using any safety light curtain, So you should know that what is the safety distance, how to use in a safe condition. So safety distance is one of the major parameters to install the safety mirror. So similarly, this is applicable for most of the safety product to know how to use. Only buying a product as a safety does not serve the purpose to achieve the safety level. Then B2 is the related to the product. So how to manufacture the product, like emergency stops, interlocking devices, safety guarding. So this is also, there is a different standard to follow, and you need to follow that safety guideline and safety standard to manufacture that product. Type C, you can see that this is applicable for different kind of machine. For example, industrial robot, ISO 12018. Similarly, like if you see here, mechanical presses, EN 692. So there is for different kind of machine, there is a different safety standards. So there is a certain process. If you see what we do into the consultancy, especially in the risk assessment, as per the ISO 12100. So first thing is that in the assessment, what we do, we define the type of hazard. So what are the hazard available on that machine? So if you see different kind of machine is a safety hazard like mechanical, electrical, thermal, noise. There is various safety hazard. I have listed out some of them, which is the major one. Second part which we follow, that hazard rating number, HRN number. Third is an important factor that which we highlighted, how to mitigate the risk. So this is very important, that after identify the risk, we have to identify how to mitigate the risk. And then we also provide that required level of safety. You know that there is a different performance level which is required. So for the certain application, certain machines, we also define which is the level of performance level required for this machine to operate in a safe condition. And there is a certain flow chart had to be followed to achieve, to make the assessment and then documentation. So if you see to minimize the risk, as per the guideline, if you see, I would like to highlight the IS standard. As Mr. Khosla has indicated that now we have like a mirror image of IS international standard and Indian standard they have adopted. So I would like to follow the IS 16819. This guideline follow the 3-step method. For example, I can show you that one is that you can see in the picture, we identify the risk. Then you have to see how to mitigate the risk. So one risk is that direct, like you are changing the design. So you can think on the designing of that machine or that application to mitigate the risk. Second method is indirect. Indirect, maybe one example, you can put the guard, safety guard to mitigate the risk. If this is not possible, then you can go for signage. For example, some of the application you may have where it is not possible even for direct, indirect, like if you see there is a heat exchanger. In heat exchanger, you cannot apply anyone. So then only option left is signage. So with this method, so like one case is that you want to avoid the hazard. Second things, you can protect the hazard. And third is that indicating hazard. So these are the process 3-step method we follow to mitigate the risk. So another, like I would like to highlight the key measure of risk mitigation. One is that separating guarding. Separating guarding has a 2 part, fixed fence or guard and movable guard. And where you need to have an interlock with the guard locking. And second part is non-separating guard. In non-separating guard, you have a different thing. Like one is the emergency stop. You can use sensitive protection equipment. For example, you can have a safety light curtains. You can have a pressure sensitive products like safety mats, safety edge, bumpers. Then you have this electrosensitive protection. So there is different devices available in the market for the non-separating guard. So then laser scanners, safety camera, 2-hand control. So there is different devices which help them to mitigate the risk in the non-separating guard. So as I mentioned previously, there is a different safety products available for. So like emergency stuff, we follow ISO 13850. Safety fence 14120. So why I'm highlighting that? as Mr. Khosla also highlighted, that they have adapted all 32 international standard to the Indian standard. So this is a complete list which we have. You can correlate that which is the Indian standard is equivalent to the international standard. So like ISO 12100, you can say IS 16819. So both are a mirror image of both. So it is just for the reference I'm putting here to use that. Already it has been adapted. Now BIS is working to implement together with Ministry of Heavy Industry to implement for Indian industry. So apart from the services, now I have highlighted the Technicum role in the market for the services. Technicum role is there, now comes into the implementations, where Simmersal and Technicum team work together to provide the complete solution. So why I mention system and solution? So if you see, one side is the machine, they review the machine, they analyze the machine, what are the things will be required to safeguard this machine, and then provide the services. So with the help of services and report, and based on report, they work to provide the complete, we provide the complete package for the safety solution. Now I would like to highlight how the market is moving to upgrade the safety level, the technology level. So first thing, if you see, earlier people are using the electromechanical devices, switches, and then coming to the magnetic device. Now the new technology is RFID, which is giving up further better to enhance the safety. Second thing, Bluetooth is also coming into the picture. Then if you see serial diagnostic 4.0 and then industry 4.0. So this is a way this market is moving, technology is moving in the market to enhance the safety automation. By considering this, you see here, Simmersal.
Overshot of time, so would request kindly conclude.
Just give me 1 minute, sir. Sorry. So Simmersal is also contributing in that to have a better technology. So like safety light curtain, having a Bluetooth, giving a lot of additional feature to have a better diagnosis in the mobile, like the voltage level, beam, like you can have a better alignment. Second thing, like there's a different layer to enhance the safety from the product to the installation system with the different interface devices to the controller, taking to the data, then to the machines, and then taking the data to the cloud. So to align with the safety, industry 4.0. Now I would like to highlight the Simmersal globally also has implemented the Global Engineering Center in India, and they are taking the safety automation to the next level, and that is our vision. So if you look at here, the engineering center together with our global team in Germany, they are working together to how to enhance this. So if you look at here, what we are going to play here, so we want to upgrade this to the next side. You can see that how we are upgrading through the safety field box, having a different communication protocol, and taking the data to the cloud to align with the industry 4.0. and on this communication is the safe communication. And here Technicum and Simmersal work together to implement this. So this is a major role of Technicum in this complete solution. Thank you very much, and thank you for your attention. Thank you.
Thank you so much, Mr. Singh. It was actually a very simple as well as detailed presentation. You covered a lot of points on the upcoming technical regulations and the role of Simmersal in implementing and achieving these standards. So our next presentation, I'll quickly go to Mr. Jayesh Jani. He is the Manager Safety Services and Certified Safety Specialist from SICK India. He will present on selecting the right safety standards for machine safeguarding. Over to you, Mr. Jani.
Good afternoon, gentlemen. It's a privilege to present about the safety. Can you please share my presentation? Yeah, as in the beginning, Mr. Nath said about the importance of machine safety and the impact of any accident, which is not only loss to the affected person, but also the industry, also the national loss, etc. If you can see, there are millions of industrial accidents happen globally every year, and they cost thousands of lives. But apart from lives, there are so many other consequences comes together with an accident, like it's cost to the company in terms of paying insurance, compensation and penalties, loss of image to the company, as well as loss of qualified workers. So how we can avoid this? That's why we are looking for to make a safe machine or provide a safe working environment to the industry. Can you please next slide, please? Now, for any machine manufacturer or any machine builder has a different, maybe a different opinion about the understanding of safety. For me, it could be a different understanding about the safety. For somebody, is a different understanding about the safety. So there should be a harmonization, or let's say common understanding about what should be the right safety standard to pick to build a safe machine. So as this is, I think, repetition for all of you, there are certain type of standards available which can help machine builder or machine manufacturer to follow how to make their machine safe. As said, that there are type A, type B. In B, there are two separate segments like B1 and B2 standard, and type C standard. So type A is generally a basic safety standards which gives us an idea how to make your machine safe, how to do a risk assessment and risk reduction. Type B is again specify how to use and which kind of safety component can be used, what should be the safety distance and all. Type C is for the specific machine, for example, robot or press machine, something like that. So type A generally it's required for all the machine, whether it is a small machine, whether it is a big machine, whether it's a simple machine or complex machine. So based on that, we have to decide which kind of product, what should be the safety distance, how should be my guards to be designed, etc. So type A and type B is common for mostly all the machines, and type C is the specific standards to be applied for a specific machine like robot or press machine, something like that. So if you can please click one slide. Yeah. So as explained, type A is a basic standard, like EN ISO 12100 is a requirement for the risk assessment, safe design and risk reduction technology. Type B1 is 13855, means the positioning of your light curtain or your safety devices on the machine, and kind of safety devices you can use. 61496 is the standard for that. And type C, as explained, is for the specific machine, like here in example 10218 is the robot standard. So if you are going to build some robot or press machine or any specific machine, then type C standard help us to build a safe machine. So by and large, it's a systematic approach. We cannot jump from A to C. We have to follow path A, B, C, something like that. Okay, so if we follow it correctly, then definitely we will end up with a very safe machine, and we can help industry to provide a safe working environment. Next, please. If you go a little bit inside about what is type A, B, or B1, B2, and C, as explained, this type A is a basic standard, or let's say it's a basic concept how to build a safe machine by starting from safe design or implementing a safety right from the design level, carry out the risk assessment, and based on risk assessment, we can decide or we can start acting how to reduce the risk up to acceptable level. So this type A standard will guide us to follow the step-by-step approach. Next, please. In a B1 standard, there are certain standards. This is just an example of 3 or 4 or 5, 6 standards, like what kind of guards and how the guards can be used, what should be the safety distance, what should be the protecting equipment positioning on the machine, what should be the gap to avoid the crushing hazard, etc. You can see 13855 is the positioning of device. 13857, the safety distance to be maintained from the immediate hazard points or crushing points, something like that. And B2 is how to use what kind of e-stop button or two-hand control or pedal switch or interlocking device to be used on the machine. So this B2 standard gives us an idea. Again, this type C, as explained, it is necessary to follow for the specific machine. Here you can see the example of robot or robotics system. So this will give you what should be the maximum robot speed while in a production, and what should be the robot speed while we are going inside the robot cell with your teaching pendant. So what should be the speed of your robot? Is there any unexpected startup possibilities there or not? So based on that, you can design your robot cell to make the people, whether it is an operator, whether it is a maintenance guy, whether it is a technician, whether it is a sweeper, anybody can go inside the robot cell, must be safeguarded by means of all this approach. Next, please. Now, you have experience or you have heard about this performance level and seal and all. So this is again a part of risk assessment. Once you decide to build one machine, there should be some idea about what should be the performance level of my machine. So it is not directly come based on risk assessment. You can arrive to a certain point. Okay, this should be the performance level of my machine, and you have to work, or machine builder or machine manufacturer has to work to achieve the required performance level, whether it is performance level A, B, C, or D. There is a certain parameter based on severity, probability of occurrence, the avoidance possibility, etc. And based on that, you can reach to a certain performance level which is required. And based on performance level you reached, you have to use these certain types of safety devices like type 2, type 3, or type 4. Based on, if you refer the standard EN 61496, then you will get an idea what should be the type 2, type 3, or type 4 device based on the performance level, what you are getting or what you are reached after carrying out the risk assessment 12100. This 13849 will give you an idea about the performance level and how performance level can be achieved. So once you reach certain performance level, you have to use a certain type of safety devices, whether it is type 2, type 3, and type 4. So many a time I noticed, because since last 4 years I am carrying out the safety inspection and risk assessment to the industry. So many a time I noticed that customer is very confused about what is the difference between this type 2, 3, and 4. Type 3 is little bit straightforward, no issue, but type 2 and type 4 is always confusing for the customer, because, for example, type 2 and type 4 are basically coming in light curtain segments. So both the light curtain will give you the same output. Once you infringe the light curtain, it will give an output. Then what is the difference? Only difference is cost. No, it's not only a difference in cost. There are certain important parameters which differentiate between type 2 and type 4 products. Okay, can you please move forward one slide? So if you go briefly, see briefly about the difference between type 2 and type 4, for example, let's say every safety product has an internal check. They check their internal status or internal health. Okay, in a type 2, it's a periodic test. And during this internal periodic test, if something is happen wrong with this safety device, and if that time, if something is approached, then there may be a chance that light curtain is not acting, and it may create a harm to the person who is going to infringe the light curtain. But in type 3 and type 4 product, this internal check is a continuous process. Means during the internal testing process, if something goes wrong with the device itself, your safety is not affected. You will get always a safe output. Your machine will be go into fail state mode. This is the advantage of type 3 and type 4 product, that during even internal testing, our safety is always maintained, while in type 2, certain period of time the safety may not be available. So this is the basic difference. So how we can use, or where we can use type 2 and type 4 product, it is again based on risk assessment. What is the risk level? What is the severity level? What is the frequency of exposure? How many times I'm going to the machine? So based on this risk assessment, once you reach to certain performance level, based on that performance level, you can decide whether type is suitable to your application or type 4 is suitable. Yeah, so this is a very brief differentiation or explanation about type 3, type 4, and type 4 product. Okay. Can you please move one slide forward, please? Now, as we explained, once we start to design any machine, once we start to decide to develop any machine, there is a 6 step to build a safe machine. First and foremost, we need to consider the law where this machine is going to be used. For example, India, for example, Europe. And based on that guidelines or directives or standards, first step is to carry out the risk assessment. And once you did the risk assessment, there is again a 3-stage approach. First, try to implement safety at the design level. Make your machine designed in such a way that machine itself called inherent design. And then do risk assessment again. If there is a risk available which is not catered or not handled by the design, then we have to use a protective device or engineering control like light curtains or safety scanner or XYZ, and do again the assessment or estimation. If still there is a risk, then you can apply administrative measure like tutor, trainings, documentation and all. And once you did all these 3-step activities. Finally, we have to carry out an overall validation of the entire machine, whether everything is still in place or whether we introduce any further risk or not. Once this validation clears my machine, then it is ready to place into the market, or it is ready to dispatch to customer, or it is ready to use for the production. And once it is reached with the documentation and all the details and certificate to the customer for the production, then risk is transferred to the end customer. Then it's become end customer's responsibility to manage and maintain the safe state of the machine, the level it reached to them. Next, please. So these are the devices available for type 2, type 3, and type 4, what we explained earlier. So with this portfolio which SICK is offering, you can select and decide which safety device is suitable for my machine, for my application, based on the risk assessment what we carried out. Okay, like light curtain, safety scanner, or safety controllers, safety PLCs, and all that you can be use on your machine. Next, please. Okay, many a time the process looks quite simple, but in reality sometimes it is not so simple, because ultimately when safety is concerned, it is always recommended to have a 4I principle. So if we have any doubt about what work we are doing, whether it is okay or not, it is always advisable to have a 4I principle. And if any machine manufacturer or end customer has any doubt about understanding of standards, understanding on safety, SICK can help to solve their problem. These are the listed services available from SICK we can offer to customer to help them to build the machine safe, to deliver the safe machine for their end customer. Like safeguarding evolution is nothing but a risk assessment. We can carry out the risk assessment right at the design level, so that there should not be any rework possibilities, because rework always costs a huge money, time, and efficiencies. So it's better to implement safety right at the design level by carrying out the risk assessment. Second is the inspection. Inspection is nothing but a validation. Once you build your machine and before it's going to the customer or before putting it to the production or use, it is always advisable to go for the inspection or validation. And last is the stop time measurement. As explained earlier by other presenter, stop time measurement is nothing but a safety distance. I notice many a time this particular aspect is very lightly taken care by the machine manufacturer or end customer unknowingly. I'm not saying they deliberately they are doing, but they don't understand the importance how and at what distance my safety product has to be installed from the immediate hazard point. It's very simple. See, safety distance can be calculated with a reference of approach speed. Approach speed is a constant. 1.6 meter per second is the walking speed and 2 meter per second is the hand speed. If I have application on press and my hand is to be protected, then 2 meter per second speed, approach speed need to be considered. And in a robot cell, 1.6 meter per second walking speed to be considered. And this approach speed can be multiplied with the overall stopping time of your machine. Means once I infringe my light curtain or scanner or whatsoever, okay, at what time my entire machine energy going to be seized, whether it is hydraulic, pneumatic, electrical energy, or whatever, okay, plus the resolution of the safety product which I am going to use on that. Now approach speed is a constant, 1600 millimeter per second for walking and 2000 millimeter for hand speed. Resolution of product is also by and large constant. Okay, the only variable part is the time. Okay, let us say my light curtain is connected with the contactor. Contactor is connected with the relay and PLC output is going to control my machine movements. So all this equipment needs some reaction time to give or generate an output. So if you calculate it manually, there may be a chance that it gives us a miscalculation or wrong calculation. Just estimate the difference of 10 milliseconds, for example, with the approach speed of 2000 millimeter can give you a wrong result of plus or minus 200 millimeter. So if your required safety distance is just for an example is 400 millimeter from the press machine, and because of this mistake of calculation, now you are going to install this light curtain at 200 millimeter, which is absolutely wrong. My machine will stop after chopping my hand, because we have already eaten the 200 millimeter time, reaction time of all this equipment, relays, contactor, PLCs, and machine and all. So there is always a dilemma at what distance we should place our light curtain, so that before our operator's hand reaches to the cutting edge, all the energy has to be seized. So only variable is time, and it has to be derived perfectly. So if you can please click one more slide. I don't know how many of you have experienced this machine, but I'm using this machine to get the overall stopping time of my entire machines and control system, okay, which will be externally connected to your machine. We are not going to disturb the control system of customers. Okay, it is externally connected, and it will give us an exact time at what time my machine will be completely halt or stop once I infringe my safety devices. And once I get the exact time, then it will be very easy, because my approach speed is a constant, my resolution is constant. So finally, I will get the exact distance where I can put my safety devices from the immediate hazard, whether it is robot cell, whether it is press machine, whether it is a conveyor or whatsoever. So generally, I'm using this machine while doing the safety inspection or stop time measurement services to my customer, to give them an exact idea whether the installation of your safety product is at right distance or not. Next, please. Now, as we explained, once you follow all these steps systematically and logically, your machine should look like this. This is the ideal safety solution. No one can challenge, no one can bother about the safety of anybody who is working in and around that machinery, because every side of this machine is safeguarded, because machine manufacturer has carried out the risk assessment. He put the design into this consideration. He took all the engineering controls in place. He put all the information and all. He considered the exact safety distance of the device and all. So once you follow this systematically and logically, your solution should look like this. And if you need any kind of help to develop this kind of solution, and if you have any doubt, you can please contact us. No problem. We will be happy to help you to build this type of situation and solution. So thank you very, very much for your time and my presentation.
Thank you so much. Thank you. Thank you so much, Mr. Jani. It was actually very nicely explained about the different types of safety standards, and also how to select the right safety product for our machinery. So that was a very nice presentation from your side. With this, we come to the last part of our session, a presentation from our colleague from the VDMA Frankfurt office, Mr. Herman Wegner, Technical Environmental Affairs and Sustainability, Machinery Safety, Electrical Safety for the non-European Union countries. Presentation is on the technical regulations, chance or change. It sounds very interesting. So looking forward to the presentation, Mr. Wegner. Over to you. Thank you.
Hello to everybody from my side, especially to Mr. Kostler, Mr. Gregor, Mr. Bani Singh, and Yanis, and my colleagues in India. Yes, I hope you can understand me very clear, because I had several disturbances at the beginning of the meeting today, but the last speakers will be able to understand. I hope it is now better. We've heard a lot about technical regulations like standards and norms, ISO, IEC, and so on. They're all very nice, and they regulate something that is very important. But in my opinion, this is the second step of all, because these technical standards, they are generally they're mandatory in use. But there is something behind, and I want to find out what this is, and I hope I can explain this to you. First of all, what is a safe machine, or what are the characteristics of a machine at all? At the beginning, it's a reliable production capability. For this point, in general, there are two parties who try to enable this. On one hand, on the first side, it's the manufacturer of the machine, because the interest is to sell a good product, and the product that in best place sells itself. And the second party in this situation is the purchaser of the machine. I think it's the same intention. The purchaser wants to buy a reliable product and a good product. And the second point, a good price performance ratio is also for these two parties very important. And the next point, lack of preventable risks. Now there is, I think we can start a little to discuss about this. On the one hand side, the manufacturer of the machine wants to be sure that there will no harm to the user of the machine, probably. But in the first view, it's that the machine may work good and will not crash in any case. No, not. Thank you. And this is also the attention of the purchaser. But if we look closer to this case, we will identify not only two interested parties, but at least at a minimum 5 interested parties. Sometimes there are more, sometimes there may be less. But in general, I think there will be 5 parties. Manufacturer and owner of the machine, I've also mentioned. Even the operator of the machine, the person who is working directly with the machine or to the machine. But there are also 2 parties that the first view have nothing to do with the machine. But if you look closer to this, then you will see, okay, no, these persons are also affected by a malfunction of the machine. Probably all persons that work on the workflow and do not work directly with the machine. Somebody who's organizing material for other workplaces, or a guest, for example, who watches the workplace and want to have an idea how the production conditions are and so on. But there is also a 5th party, and if you mention, you try to follow. I've been working for companies producing machines for foodstuffs, and if you look at these machines, then you will see there are customers who will buy these foodstuffs, and these people also have to be protected from any harm that maybe arise from the machine. There shouldn't be any broken parts in the food, and the surface of the food that is in contact with the machine must not be or shall not be negatively influenced from the surface materials and so on. And from this point, these 5 parties, they describe or they define the basic requirements for a safe machine. Next slide, please. Yeah. So these technical regulations to enforce these requirements of these 5 parties often seem to be a chain or a burden, because the original definition of safety parts or safety design is that it could be left without influence to the capability of the machine for production. So what means you can leave all these safety devices or honored organizations and companies they have here introduced, but the machine will work without completely without them normally, and it is also this is productive but not safe. And to enforce this safety to the machine and to the production must or is regulated in the technical regulation. And these technical regulations are also mentioned to protect the machine's operators and strengthen the responsibility of the owner of the machine and to have an eye on the product he's chasing and is producing with, and that the products that come out of the machine are safe to all the people in the chain behind. And these technical regulations, they emphasize the responsibility of the producer of the machine and producer of products that are produced with the machine. Sometimes these technical regulations seem to be a significant restriction of the degrees of freedom in design. Yes, and they sometimes are. And, for example, in Europe, we have quite strong pressure for this in this point, because we have a lot of regulations that do not only have machinery safety in mind, but also the use of materials. So there are a lot of materials that are forbidden in Europe, and the number is still increasing. Next slide, please. But these chains are also a chance, because technical regulations also ensure the comparable conditions for all competitors. What does this mean? If you can only sell a safe machine, then there is a minimum of safety for the machine purchaser can rely on, and you can focus on probably some other aspects from the machine. Market surveillance is much easier, because the market surveillance can much more easier check if the products are safe, because they have a list where they can check the safety of a product and of a machine. And these processes make the market surveillance, the process of market surveillance, much more reliable. The procurement process is more reliable, as I also already mentioned, because you can rely that you will get a safe product, because this is from origin the task of the producer of the machine, and you don't have to describe the safety characteristics of the product. It makes it much easier. And the comparability of the different offers for machines is much better to compare in this situation. And but there is the little problem in this point is a conclusive minimum requirements for basic product characteristics. What does this mean? Public requirements, they describe the safety of the product and the minimum requirements, but the manufacturer himself can decide how much safety the machine in its eyes will need additionally. And the idea of this complete philosophy is to create a level playing field for all manufacturers. What means that nobody can, let me say, jump too short what is in accordance with product safety. Thank you. Next slide, please. Thank you.
Thank you. Thank you so much, Mr. Wegner, for the excellent presentation. And with this, we come to the end of our session. We will go to the question answer round, and we have some interesting questions from the audience for the speakers. Definitely, we'll send all the presentations to the participants after due permissions from the speakers. So, but still, if you have any question, you can put up your question on the chat box. I would request Mr. Rajesh Nath to kindly moderate the question answer session, please. Over to you, Mr. Nath.
Yeah, thank you all the speakers. I think we had excellent presentations, a really interesting presentation from all the speakers as well as from Mr. Khosla also. We are running short of time, that's why I will just quickly maybe take a couple of questions. We won't have time for all the questions, but then we'll try to send across the questions. So the first question maybe for Mr. Ramji Singh. Ramji, this is EC type. Ramji, are you there?
I'm there.
This was on the basis of your presentation, Ramji. Is EC type examination certificate with EN 201 standard valid for EN ISO 20430 standards?
Yes. So thank you, Mr. Nath. So basically, I can tell you this. There is a first declaration in the month of July 2020 that new standard ISO 20430, which has replaced EN 201. So basically, 201 is going to be obsoleted, and this new standard has come, the ISO 20430, and first notification we received in the month of February to implement in 2021. But so it is clear that now you have to follow, because this is standard related to the plastic and rubber machinery, and this has come to implement, but there is no any clarity that whether he can use the same certificate. This clarity is still pending, because this is a very new development which notification we got in February. So once we will have a clarity on this point, we can update to the Mr. Chetan Pandya.
Okay. Right. Then one more question that is there is, which ISO standard is applicable for pump safety under B2?
So for the pump, I can say there is two things. One is the EN 13951 and ISO 1630330. These two standards followed for the pump safety. Sorry.
Right. Can you repeat that, Ramji, once more, please?
One is the EN 13951 and ISO 1330.
Mr. Khosla, the last question maybe I'd like to address to you, a very general question, is because of COVID impact, Mr. Khosla, and all the disturbances and disruptions, so are there delays that are happening in implementation of certain standards, Mr. Khosla, or things are normally on schedule?
Am I audible?
Yes, Mr. Khosla. Yes, please.
Yeah, actually, it is not in case of Department of Heavy Industry, as well as all other ministries have presently postponed the regulations that they were about to bring by a period of approximately 1 year. So maybe they will review it. I think most of the regulations that were there under Ministry of Commerce, they have told that the dates have been, which the dates were already given in 2021, have been extended to 1st January 2022. So similarly, I expect that DHI also is going slow on this regulation, though nothing official has been communicated by them. But I think they will review the situation once the COVID situation eases and some normality of business is achieved by the industry in India. I do not expect that any regulation to come about very soon because of the COVID situation. So though no official word is there, maybe DHI, Department of Heavy Industry, can clarify it on a more specific basis. But in general, I'm seeing all the ministries have postponed the regulation or implementation of regulation by a period of 1 year. So all the regulation that were to be implemented in the year 2021 have already been postponed to 1st January 2022. So I expect similar case in DHI as well. So like I told you, no specific guideline has been issued by them.
Sure. Thank you. Thank you for this clarification, Mr. Khosla. Yeah. So friends, with that, I would like to conclude. We have some more questions, but we are already running short of time. So I would like to convey my sincere thanks to Mr. Khosla from Bureau of Indian Standards, Mr. Gregorius from Phoenix Contact, Mr. Amol Bari from PILS, Mr. Ramji Singh Shmazal, Mr. Jayesh Jani from ZIC, and of course, Mr. Herman Wegner, my colleague from VDMA Frankfurt. I would also like to thank Ajmal for moderating this session. Also, thanks to the participants. We had a good number of participants, and many of the participants have stayed till the very end of this webinar. So thank you, members, as well as industry colleagues who have participated in this webinar. And I would like to conclude with an interesting quote from the Colorado School of Mines magazine. What they have mentioned is, you don't need to know the whole alphabet of safety. The ABC of it will save you if you follow it. A, always be careful. So I think that is very ABC. If we follow, always be careful. I think that sums up a lot of details on safety. So thank you all the speakers, presenters, all our participants for joining today. Mr. Khosla, special thanks to you that you've taken time to be with us. So thank you very much. Stay well, stay safe, friends, and all the very best. Thank you. Goodbye.
Thank you very much. Thank you very much all. Thank you.
Thank you very much for all the audience for joining this. Thank you.
Thank you for organization. Goodbye.